Now let's go and look and summarize the types of discontinuities we have. And we have, for example, jumps, and one of them is going to be an example of, for example, absolute value of x divided by x. And the other one, it might be like -3 to the left and 3x plus 1 to the right. I will enter both of these. Let's do the absolute value of x over x. You get the absolute value, the ABS from the catalog, right here, the catalog, and it's the first thing in there. So you can enter that. And let me show you that graph first. Here it is. And there is a jump in there. It's not continuous at 0. Let's enter this one. To enter that one, it's a step function. I have to make this inactive, and this one active, and this one active. And this is how I do it. I just go in there and push enter. And you can enter these things with the braces, for example. You can also enter them like I showed you with slash and left parentheses. There are two ways of doing it, so I showed you both of them. You get the less than or equal to and greater than, those from catalog, from right here. You can go up and get those buttons. And they're right here, as you see. Now, when you want to do that, and I made those two active, here's one, and here's the other one, as you see. Alright, so these are jumps. They are discontinuous at these points. Let's go and look at some other types of discontinuities. It may be an oscillating function, something like sine of 1 over x, and it's going to show up something like that. And let me show you how that is. Let me make this inactive, inactive. And I want to make sine of 1 over x. But this time I want to focus in a little bit. Let me change the window. I go window, I will go -2 to 2. -2 and 2. And here -2 to 2 as well. So I go -2 to 2. And push graph. And you can actually see the oscillation right here. Very good. So that is also an discontinuity. It's an oscillating one. Alright. Let's go at asymptote discontinuities. We call them infinite discontinuities. And that is an example like 10x. And let me make this inactive and this one active. And you can change your x-min and max. And for example, I'm going from -2 pi to 2 pi. And I will change that, and let me show you. -2 times pi. And you can take the pi right here from the second up button. And then you see when I go down and it changes back. 2 times pi. Here it is. Alright. And y-min, let's go from -4 to 4. I'll change that. -4 to 4. And you're going to see those vertical asymptotes when you do that. And graph. And here they are. So here's the 10. And there's a discontinuity at these points. They're infinite discontinuities. It's another type of discontinuity. Now, let's look at intermediate value theorem. Now, let's say we have an f, and it is continuous on a closed interval AB, and n is in a number between f of a and f of b, and f of a and f of b are different. Then there is a number c in AB such that f of c equals n. Alright, what's that mean? Alright, here's my a, here's my b. A has a value f of a and b has a value f of b, and they're different. There is a number n between f of a and f of b. And then when I take the x corresponding to that, and that x is going to be necessarily between a and b if there is no break in the function. Well, what can I do with this thing? Actually, there is a great application, and we can show that there is a root for an equation, for example. And how do we do that? Let's take a function, 4x cubed minus 6x squared plus 3x minus 2 equals 0. And I want to show that this guy has a root between 1 and 2 or someplace in that vicinity. Alright. Now let's look at that. And if I do it by hand, I can put in 1. It doesn't have to be 1, between 1 and 2, but it's something in the vicinity. And when I put f of 1, I get a negative 1, which is 0, which is less than 0. When I put 2, I get 12, which is greater than 0. What does that mean? There is this function, if there's no break, has to go through 0. Because on one side I have negative 1, on the other side is 0. It has to go through 0, through the x-axis. And that means there is a root between 1 and 2. Alright, so let's look at that. And I will do this with the graphing calculator. Let's go enter the 4x cubed minus 6x squared plus 3x minus 2. And I entered that here using this button for x. And I picked 0 for my lower end and 3 for my higher end. And I want to show that when it's 1, I get negative 1. When it's 2, I get 12. So I will show all this in there. And let's graph it first. Here it is. So let's go and let's get the values. And you do the values using this calculate button. Push calculate value. And put 1. Do you see that? And push enter. And here we go. I get a negative 1. Or here it is. It's negative. So let's do the same thing with 2. And I'll put x equals 2. Alright, here we go. Y equals 12. That's a positive. Well, what does that mean? There has to be something in between. Alright, and you can actually go and trace that value. Since I was here, and this is continuous, it has to go through here. And I can trace it. And watch, when I trace, where am I? I am too far, so I want to see. Here it is. I can trace it, and it looks like it's like 1.24, and it's like around here someplace. Okay, to get a better estimate, you can keep on zooming in. Okay, so keep on zooming in. I'll just go in here, and I'll use the zoom button. And not zoom box, zoom in and push enter. Here we go. Now I'm a little closer. And I am around there, and I will zoom in again. Say zoom, zoom in. I'm even closer. So you can actually go and get the trace. And you see it is not too bad. And to the left, it's like around 1.2 something. It's still negative 1.22 to 1.21, around there, okay? If I want to get the exact value of that, you can also use the calculate feature and get the 0 of that function. Watch. 0 is also built in. Push enter. Left bound, find, pick something on the left. Right bound, pick something on the right, so that it's to the right of your root. And guess, you can guess the same value, and it will go 0 it in. It's actually 1.2211248. Okay, I got a lot of accuracy there.